Have you ever wondered if you could travel back in time? What would you change? Now imagine, if you will, the ability to move between different points in time as easily as you would between different points in space. That's what we refer to as time travel, a theoretical concept that has intrigued scientists and futurists for centuries. But, as with any concept that challenges the laws of nature, there are complexities to consider. One of these is the idea of a paradox, a situation that seemingly defies logic or presents an inconsistency. In the realm of time travel, we encounter what's known as a time paradox. This is a contradiction that occurs within the timeline, a result of the actions of a time traveler. These paradoxes pose significant challenges to the feasibility of time travel and raise questions that scientists are still grappling with. So, if time travel is possible, why haven't we met any time travelers yet? Imagine going back in time and accidentally preventing your grandparents from meeting. What happens to you? This is the premise of the grandfather paradox, one of the most well-known contradictions associated with the concept of time travel. The grandfather paradox is a thought experiment that explores the contradictions that could result from changing past events. Picture this. A time traveler embarks on a journey to the past. For reasons known only to them, they decide to prevent their grandparents from meeting. Now, if their grandparents never meet, they never have children. This means the time traveler's parents are never born, and consequently, the time traveler themselves never comes into existence. But here's the twist. If the time traveler never exists, then they couldn't possibly have traveled back in time to prevent their grandparents from meeting in the first place. This creates a loop of causality, an infinite cycle of events that contradict each other. The existence of the time traveler depends on their non-existence, and vice versa. It's a head-scratcher, isn't it? This paradox is an example of what's known as a causality violation, a disruption in the cause and effect relationship that we're used to seeing in our everyday lives. In the world as we know it, causes always precede their effects. You press a light switch, the cause, and the light turns on, the effect. But in the grandfather paradox, the effect, the time traveler's non-existence, precedes its cause, the prevention of the grandparents' meeting. Some theorists propose that these paradoxes could be avoided if time travel were to operate on a multiverse model, where each action creates a new parallel universe. So, in preventing their grandparents from meeting, the time traveler would simply create a new universe where they don't exist, while still existing in their original universe. This paradox raises the question, is time travel really possible, or are these paradoxes proof that it can't exist? As we delve further into the mysteries of time and space, this question continues to captivate us, challenging our understanding of the universe and our place within it. What if you found a book full of future predictions and decided to publish it as your own? Welcome to the world of the Bootstrap paradox. This is a time travel paradox where an object or piece of information is sent back in time, creating an infinite loop in which it has no discernible point of origin. It's like the chicken and the egg conundrum, but on a cosmic scale. A classic example is the book scenario. You find a book that details future events and you publish it as your own. Then, someone in the future finds your book, travels back in time, and leaves it for you to find. The book, in essence, creates itself. But where did the knowledge initially come from? That's the Bootstrap paradox. Now let's take a leap into the Novikov self-consistency principle. This principle suggests that any actions taken by a time traveler or any events that they influence were always part of history. In other words, you can't change the past, because any attempt to do so will simply become part of the past itself. It's a safeguard against the grandfather paradox, which we discussed earlier. If you went back in time intending to stop a major event, according to Novikov, you'd fail. Why? Because that event is already part of a fixed and unchangeable history. You were always there, always part of the story. In essence, the Bootstrap paradox and the Novikov self-consistency principle explore two different yet fascinating aspects of time travel. The Bootstrap paradox challenges our understanding of cause and effect, while the Novikov principle presents a time loop where everything is predetermined and unchangeable. So, could time travel exist within a self-consistent universe, or is it all just science fiction? Perhaps we'll never know, but isn't it exciting to ponder the possibilities? So, what have we learned about time travel and its paradoxes? We've delved into the enigma of time travel, a concept that has intrigued scientists, philosophers, and dreamers alike for centuries. We've explored the contradictory nature of time travel paradoxes, starting with the grandfather paradox, which questions the possibility of altering one's own timeline. Then we moved on to the Bootstrap paradox and the Novikov self-consistency principle, which delve into the complexities of cause and effect when applied to time travel. These paradoxes underscore the intricate web of uncertainties and speculations surrounding the concept of time travel, raising fundamental questions about the nature of reality and our place within it. We might not have all the answers yet, but the questions themselves are invigorating, pushing the boundaries of our understanding and encouraging us to think beyond the confines of our current knowledge. Whether time travel is possible or not, it's fascinating to think about the possibilities and paradoxes it presents. Until next time, keep pondering the mysteries of the universe.